You know how your favorite app just knows your playlist, or how an online store can keep track of millions of different items? Well, the secret sauce behind almost all of it is a language called SQL. And in this explainer, we're going to break down exactly what that is, the universal language for talking to data.
And believe it or not, it all started right here. Back in 1970, this researcher at IBM, Dr. E.F. Codd, published this one academic paper. That's it. It wasn't a fancy new computer or some piece of software. It was just an idea. But wow, this one idea would go on to completely change how we handle information.
And what's just mind-blowing is that this concept, from all the way back in 1970, is the invisible engine running your entire digital life. Seriously, every single time you scroll through a social media feed, stream a movie, check your bank account, you are, without even knowing it, interacting with a system built on the ideas from that one paper.
Okay, so to really get why Dr. Codd's idea was such a breakthrough, we have to understand the huge problem he was trying to solve. The problem of, well, organizing all the world's data.
I mean, just think about it for a second. You've got customers, you've got products, orders, dates, locations, billions of these little disconnected pieces of information. How in the world do you store all of that in a way that isn't just a total chaotic mess? And more importantly, how do you find that one specific thing you're looking for without having to dig through everything every single time?
Well, Dr. Codd's solution was just beautiful in how simple it was. He basically said, hey, what if all data, I don't care how complicated it seems, could be organized into a collection of simple tables? Now, this was a huge deal. It was a massive shift away from the really rigid, clunky, tree-like systems they were using before. And this new idea, the relational model, made data incredibly flexible and so much easier to work with.
So if we think of that relational model as the grand blueprint, then the table is the most basic building block. It's like the individual brick we're going to use to build our entire data house.
See, a table isn't just some random grid of boxes. No, it's a very specific blueprint. What you're looking at here, for example, is the structure for a customer table. It defines every single piece of information we're allowed to store about a customer, their ID, their name, their email. It even gets super specific about what kind of data each column can hold. And we'll definitely circle back to that in a minute.
Right. So every table, doesn't matter if it's got 3 entries or 3 billion, is made up of 2 key parts, rows and columns. Let's break down exactly what that means.
Okay, so here's what that blueprint looks like when it's filled with actual data. This is from a fictional movie rental store. You can see it right there. All the information for Mary Smith, Patricia Johnson, and Linda Williams, all just neatly organized.
So a single row, you'll also hear it called a record, represents one complete thing. Think of it like a trading card. In this case, that first row is the Mary Smith card. It's got everything we know about her, her first name, last name, and email. It's this neat, self-contained packet of information all about one person. A column, though, is totally different. It represents a single piece of information, a single attribute, but for every single record in the table. So that last name column doesn't just hold one person's last name, it holds the last name for every single customer we have. And this structure, this grid of rows and columns, is what makes the data so powerful and so incredibly easy to search through. Okay, so we've got our data, it's beautifully organized in these tables. Now what? How do we actually talk to them? Ask questions and get answers back. Well, that's where SQL comes into the picture.
SQL, which stands for Structured Query Language, is pretty much exactly what it sounds like. It's a language, a programming language, designed for one specific job, communicating with a database. It's how you ask to retrieve data, add new data, or even update old data. It's the universal translator between you and all that organized information.
And the great thing about a basic SQL query is that you can really just break it down into 3 simple plain English questions. First up, what information do you want? That's your select statement. Second, where is this information hiding? That's your from clause. And third, what specific rules or conditions does the information need to meet? And that's your where clause. Select, from, where. That's the core of it.
All right, let's see how this works on the real world. Here, we select the ID, first name, and last name columns. We tell the database the information is from the person table, and we add our condition with where. The last name has to be Turner. The database gets this command, instantly scans the table, and bam, it gives us back only the one single row that matches our exact request. It's just that precise.
Now, for a database to work this fast and this efficiently, it needs one more crucial piece of the puzzle. See, it's not enough to just throw data into a column. The database has to know what kind of data it's storing.
Yeah, a database needs context. It has to know that the text apple is a very different thing from the number 100, which is also completely different from the date October 26, 2024. By telling each column what its data type is, we make sure everything is stored efficiently. And it also means that when we do things like sorting or math, the results actually make sense. You can't add apple to 100, right?
So for text, for example, you've got different options depending on how much space you need. Something called a varchar, which just means variable character, is perfect for things like names or email addresses. But if you needed to store, say, the entire text of a book, you'd use something way bigger, like long text.
And it's the exact same idea for numbers. If you're just storing how many items are in a shopping cart, a tiny int that only goes up to 127 is probably all you need. But if you're creating a unique ID for every single financial transaction on the entire planet, you're going to need a big int to make sure you never, ever run out of numbers. It's all about picking the right tool for the job to be as efficient as possible.
So let's do a super quick recap of these fundamental building blocks. We've got our data organized into tables. These tables are made of rows, which are complete records, and columns, which are specific attributes. We use the language SQL to ask these tables questions, and finally, data types make sure every column stores the right kind of information. That's the core of it.
And that's it. That's the foundation of how pretty much all the world's digital information is organized and accessed. These simple concepts, tables, rows, columns, and a language to talk to them are powerful enough to scale up and handle an absolutely unimaginable amount of information. You've just learned the basic grammar of datasets. So the real question is, what questions will you ask?